All right, we're just gonna pick off where we left off. Quick review, not a whole lot. It is a linear equations chapter. Three forms of a linear equation. There's the standard form, where it's going to be something like this. For example, 3x minus 4y equals 12. Right? What's the y-intercept? What's the slope? It's not possible to see unless you shuffle it around. That's the standard form of a linear equation. What you can do is you can toss the negative, the 3x to the other side, and then you can divide by -4 like this, and this gives you the slope intercept form, where this is the slope, that's the m value, the slope, and this up here is the y-intercept. Okay, these are the two you usually see. Sometimes you're going to see this one as well. Y minus y1 equals m bracket x minus x1. Now in this case, you have the slope, just like we did in the other equation here, but you also have, you don't have a y-intercept here, mind you, but you have a point, x1, y1, any point. It can be any point on that line. You plug that in there and that'll give you the equation. Once you have the equation, it's kind of easy, right? But in this unit, they will not give you the equation. You're going to have to come up with one by yourself. It's always going to look something like this, or it's going to look something like this, okay? We just have to see what it is. Let's look at a question here. So there is a paving company that charges $10 per square foot and a $40 delivery fee. See right here, we already know what the equation is. What's the equation? One of these is going to be the slope. One of these is going to be the y-intercept. They've only given us two numbers. What do you think? Which one's the slope? Which one's the y-intercept?
10 is the slope.
Yeah, 10 is the slope. So y is going to represent the area of the paving stones. Okay, y is the area. And no, actually y is not the area. X is the area. Y is the price. Okay, price is dependent upon area. That's why y is going to be the price in dollars, and area is in square foot. Okay, that's our x and y. Therefore, the equation is going to look like this. Y is equals to 10x plus 40 is the flat fee. That's going to be the y-intercept. Look at question A. It says determine the greatest area that he can pave if he has $3,500. So is that our y value or our x value? Where do we plug this?
The y value.
The y value, right? Super simple. You just plug y as 3,500 and then you're going to solve this for x. This is going to be 3,460 equals 10x. Therefore, x is going to be 346 square foot. Okay, so that's the area he can pave with that amount of cash. Pretty expensive. Part B. Andrew needs to include 5 cubic yards of sand costing 15 per cubic yard to the total cost of the project. How will this cost reduce the area that he can pave? All right, so part B, we need to include something else in the budget, which means our area is gonna go down. Any ideas on how to approach part B? Think about it like this. What's the cost just for the sand? We need 5 yards of it, right? and each yard costs $15. So the cost of sand alone is going to be 15 times 5. It's going to be $75. Okay. That means from his budget, the money he has left for the paving is going to be 3,500 minus 75. So what's going to change here is this. This will be 3,500 minus 75, which is 3,425. Okay, so that's the only thing that changes. Now the budget he has for the paving is going to be 3,475. Sorry, 3,425. You take away 40 from that, you're going to get 3,385 equals 10x. Therefore, the new area is going to be 338.5 square foot for part B. That makes sense? That's it for this question. Pretty simple. This question comes with a picture. I don't know if it's important, probably not. But we're just gonna put it on the side for support purposes. So at 9 a.m., she starts jogging north at 6 kilometers per hour. By the way, before we do this question, understand this. There's this triangle where you have distance up here, okay? You have speed down here, speed, velocity. For our purposes, it's the same thing. But remember, speed is a scalar quantity and velocity is a vector, okay? But at this level, we can kind of use them interchangeably, unless we're doing like a physics question. But this is more mathematical, so we don't care. We have distance, we have speed, we have time. Distance is going to be speed times time. Okay, this is the critical equation, which means your speed is going to be divide both sides by t. It's going to be distance divided by time. And the equation for time, you swap places with s. Time is going to be distance divided by speed. Okay, that's how these three things are related. And probably we're going to need one of these equations to answer this question. So at 9 a.m., she's going north at 6 kilometers per hour from the south end of a 21-kilometer trail. At the same time, another person starts cycling south at 15 kilometers per hour. Use a graph to determine where they will meet. Cool. So what's happened here is this. So there's a path. The distance of this path is 21 kilometers. We have someone going from here to here at 6 kilometers per hour. And then we have another person coming from up there at 15 kilometers per hour. And we want to find where they are going to meet, okay? That's the question. So I think they're asking us for when. I think they're asking us for the time. Alrighty. So how do we approach this question? Any ideas? It's pretty tricky. It's a T question as well. Again, remember T means thinking, so you have to, the math portion is going to be easy, but coming up with the equation is going to be a lot more difficult. We're going to work at it like this, okay? Let's say they meet, okay? Let's say they meet after X hours. When they meet, okay? Meet. Whenever we start 9, so X just represents the time. So let's say they meet after X hours. Cool. And what else do we need? We have time, we have speed, we have the distance. So let's come up with equations for Chantel. which is a lady going from down here to up there. What's going to be the equation for time for Chantel? Remember, time is distance over s, yeah?
Mm-hmm.
You can also look at it, I guess this is the best approach because they're asking us for time. Your unknown is always going to be whatever they're asking you, okay? You can think about it like this, actually. There's another approach to this as well. So after 1 hour, right, where's this person going to be? If this distance is 21 kilometers, yeah?
Mm-hmm.
After 1 hour, this person is going to be over here, right? Where this distance is going to be 15 kilometers. Yeah.
Mm-hmm.
What about this person? After 1 hour, where's this person going to end up? He's going to end up right there. Notice this person, after 1 hour, she's going to travel 6 kilometers up. Yeah. To this point, 6 kilometers up. Similarly, the other person is going to end up traveling 15 kilometers south. He's going to end up right there, and that's where they're going to meet. Make sense?
Mm-hmm.
So after 1 hour, they're going to meet right there, where this distance is 6, and that distance is 15. Okay, I guess that's the easiest way to go about it. There's multiple ways. It's a T question. There's multiple ways. That would be the easiest way to go about it. So they're going to meet at 10 a.m. And that's it for this question. Let's look at this. The owner of a throwing stand pays 75 cents every time the bullseye is hit, but charges 25 cents every time it is missed. After 25 tries, Luke paid $5.25. How many times did he hit the bullseye? So for this question, okay, it's very important to correctly identify what X and Y is. What do you think X and Y is in this question? If you have this, the question is in the bag. Okay, let's go back to this question. Again, someone's throwing some darts. If they win, they get paid 25 cents, but if they miss, they lose 25 cents. After 25 tries, Luke paid $5.25. How many times did he hit the bullseye? So again, this question is a little bit tricky. You need to be able to identify what X and Y represent. What do you think X and Y is in this question?
Is X the amount of times he hit the bullseye?
Yeah, that is it. X, we can say X is hit, and Y is miss. Okay? X is the amount of time he hits, Y is the amount of time they miss. So what's the equation here? There's gonna be, this one's tricky. There's gonna be two equations, okay? There is going to be two equations in this question. The first equation is the money equation. So 75 cent is hit, so you get 0.75x, okay? This is the money made if you hit, minus 0.25y. Now, why is this minus? Because you lose money if you miss, okay? And
Mhm.
equals to, this is going to be equals to the money that he paid, which is 525. Again, this is the money earned if you hit, okay? And this minus there because you're going to lose. That's the money lost when you miss. And that's our first equation. That equation has two unknowns, so you can't really solve it. So what do we do here? We need to come up with a second equation, which is going to be the attempts. So he landed X times, yeah?
Mhm.
He missed Y times, but we're counting the attempt. That's why this is a plus. What's the total number of attempts?
25.
25. There you go. So this is going to be our equation. Now, how do you solve? Now this becomes a system. System means you have multiple equations. This is a system of linear equations. How do you solve a system of linear equations? Do you remember? Two ways. You can either do substitution or you can do elimination, okay? For this question, I'm going to do substitution. Check this out. I'm going to substitute, I'm going to throw the x to the other side. So you get an equation for y, okay? Y is going to be 25 minus x, and I'm going to plug this as y up here. If I do that, I get one equation with one unknown. So it looks like this. 0.75x minus 0.25, okay? Now this is called a substitution. We're going to replace y with 25 minus x, and this is going to be equals to 5.25. To solve this linear equation, now it's pretty simple. You just open that bracket. Get this. What's 25 times 0.25? I think that's a quarter, 6.25. Okay, and then it's going to be plus 0.25x equals 5.25, like that. From here, it's easy. You have like terms here. 0.75 plus 0.25 is 1x. And then 5.25 plus this guy here will be 1150, okay?
Mhm.
There you go. And that's the answer because we're looking for x. How many times did he hit? 1150. I guess you can say this is 11. He hits it 11 times. Cool?
Mhm.
So that's how you would solve a system of linear equations. Sometimes you can get even 3 equations. Very rare, but you can get 3 equations. That's the approach you want to use. Let's move on to the next thing, graphically solving a linear system. Kind of a simple idea. For this one, you want to be precise with the scale drawing. So when it says solve using a graph, what it's asking you is to find the point of intersection, okay? The first one here, y equals 2x plus 1, the y-intercept is 1, right? The slope is 2. That means you go up by 2 units, and then you go across by 1. That makes sense here? Slope is 2, it's the same thing as 2 over 1. So you go up by 2 units, you go across by 1. So you have this point, you have this point here. You just need 2 points for a linear line. You connect them. Again, this one like that, and then I don't know if that's a perfect connection. This one looks better. There we go, that one, and then you want to do it on the other side as well. Something like that. That's the first equation. The next equation is not in the right form. How do we graph this? You could take it into y equals mx plus b, but you don't have to. What's the y-intercept here for this equation? Remember, y-intercept is when x is 0. The y-intercept is -4, okay? To find the y-intercept, you just set x equals 0, you ignore the x. What 2y equals -8, y equals -4. So the y-intercept is -4. 1, 2, 3, 4, right there. What is the x-intercept? For this equation? X-intercept is when y is 0. In other words, you ignore the y component. That'll give you the x-intercept. No?
So it's just -8.
It's just straight up -8, yeah. You can do it this way. You can always take it into y equals mx plus b as well. 4, 5, 6, 7, 8. -8 is there. And then you connect this. And wherever they meet is going to be the point of intersection right there. So that point is -1, -2 on the x-axis, and -1, -2, -3 on the y-axis. There you go. That's the point of intersection. Okay? Very simple idea. Just draw them out. We know how to graph linear lines. We've done this hundreds of times. Here's another distance question. So we're going from somewhere to somewhere, Kitchener to Smiths Falls. The distance is 450 kilometers. She travels along one highway at 100 kilometers per hour. So let's say this part here is the first highway, 100 kilometers per hour. And then another one at 80 kilometers per hour. So let's say this one down here is 80 kilometers per hour. The trip took 4 hours 45 minutes. What is the distance from Kingston? So this is Kingston. So we had two Ks. I'm gonna call this maybe W, so we don't get confused. So this is our initial point, Kitchener-Waterloo to Kingston. Okay, this is the middle thing. What's the question asking you? What's the distance from Kingston to Smiths Falls? So the question is asking you for this distance here. We know the total distance is 450, okay? It's asking you for this distance here. Again, important. What's our x and what's our y? It's always easy if you just make x as whatever they're asking you for, okay? So I'm gonna say x is the distance from here, Kingston, to Smiths Falls. That's our x, okay? So x is our unknown. Basically, the distance from Kingston to Smiths Falls is x. That means this is gonna be our y, the distance from Waterloo to Kingston. Cool? There's gonna be, I guess, two equations for this one as well. What's the distance, total distance equation in terms of x and y?
450.
Yeah, so it's gonna be x plus y is gonna be equals to 450. That is our first equation. The next equation is going to be the total time. Now this one's a little bit trickier. Total time. We know the total time took 4 hours and 45 minutes, which in terms of hours, again, don't be confused here, it's 4.75 hours because 45 minutes is 3/4 of an hour. Remember this as well, distance is equals to speed times time, okay? So that means we're looking for time. Time is going to be distance divided by speed. What's the time from W to K? Well, we know the distance is y, okay? The distance is y from W to K. We're using this formula here. And the speed is 100, right? Like that. Make sense? What about the other time from K to S? What's the time from here to here?
It's x over 80.
Yeah, that's x over 80, like that. I don't want to graph this. I just want to see how they do it. They did graph it, but graphing that is not easy because you have divided by 80 and whatnot. They're not asking us to graph it. I don't want to graph that at all. So how do you solve this equation? Again, notice it's a system of linear equations. Ideally, you want to do substitution. Okay, so x is our missing component. So I'm going to say y is equals to 450 minus x. I just moved this x to the other side. Once you have your y in terms of x, you want to plug that into the second equation. So you get x over 80 plus y is now going to be 450 minus x. This is the substitution component. Divided by 100 is equals to 4.75. Now we have one equation with one unknown x, which is also what the question's asking us. How do we solve this linear equation for x? Any ideas? It's just a linear equation. You want to take the LCD, okay? What's the LCD between 80 and 100, the lowest common denominator? It is 400. 80 times 5 is 400. 100 times 4 is 400. So what this means is you need to multiply this by 5, okay? You need to multiply the other guy by 4. It's going to look like this. 5x plus 450 times 4, I think is 1800. Yeah. Minus 4x like that. And in the denominator, you have 400 equals 4.75. Whenever you have a fraction, just take the LCD. What do we do next?
Multiply by 400.
Yeah. Multiply both sides by 400, so you get x plus 1800 is equals to 400 times 4.75. That gives me 1900. Therefore, x are unknown as 100 kilometers, which means if they asked us for the other distance, that would be 350. So y would be 350 kilometers. But this is our answer to this question, the unknown. Okay? This question, a little bit tricky. You need to know some things about distances, and you need to know how to solve a system of linear equations. They graphed it, but the approach with this one is that it's not very precise, you know? Like, where's 380, you know? Where's 380? Where's 475? Especially when you're going up on scales of 50 here, each box represents 50. Yeah? I don't know how they did it. They cheated. I'm pretty sure they used a graphing calculator, but doing this by hand is next to impossible because the scale is 50. 380 could be like here, could be like here. So sometimes graphical approach is not the best, especially when you have large numbers. It's good if you have like 10, 15 or whatever, because 380 is very close to 379, 378. There's no way to quite pinpoint that when the scale is 50. Let's look at this. Super simple question. What's the first equation? Y is the bill, okay? Y is the price, and X is the kilometers. So this one is going to be in our slope-intercept form. The first one will be 0.15x plus 95. What's the other equation?
0.26x plus 50.
Plus 50, right? The question's asking you which company charges less. Well, it's going to depend on your kilometers. I'm sure they graph this as well, and the graphing this is also not that easy. They use a graphing calculator. So let me just show you how to approach this question. That kind of defeats the purpose, you know, like if you're going to use a graphing calculator, I'm going to plug those two equations in. What were our equations? 0.15x plus 95, 0.26x plus 50. So the top one is red, okay? The Kelly's cars is red. Look at this question. How would you answer this? The question is, which one charges less? Let me just pull this up. Okay, there we go. This blue one is the Rick's, and the red one here is Kelly's. Or yeah, Kelly's. How would you answer this question? Which one charges less? The answer isn't as straightforward. Yeah, there's no one answer. It depends on the kilometers. Notice they meet over here, yeah?
Mm-hmm.
So at this point, their Y values, remember Y is the money, the bill that we're interested in, that their Y values are exactly the same, right? That's the POI. So if you're driving 409.09 kilometers, it doesn't matter which one you go with, okay? They're both charging you the exact same amount. But if you're traveling for less than 409, you see, if you follow this line here, if you're traveling for less than 409 kilometers, then Rick's, the blue line, is better. Okay? If you're traveling for more than 409 kilometers, the red line is better. Cool?
Uh-huh.
That's it. That's the answer. So there's not one answer. It depends on the kilometers that you drive. So this is for a weekend. Probably you would end up driving 409 kilometers if you're going out of town. But anyways, that's the answer. There's no one answer to that question. Most of these questions are elementary. I'm looking for some things better. All right, we can look at this one. Or if I give you a question like this, you can do it like identify the point of intersection, doesn't matter. Even this one, graph the system, solve the system, you just graph it, right? Look at this, for this one, the y-intercept is 5, set x as 0, the x-intercept is also 5. For this one, the y-intercept is 3. If you set 3x as 0, for y equals 12, y equals 3, that's the y-intercept. For x-intercept, you want to set, or ignore this, set this as 0. The x-intercept would be 4. And you just graph it. You're going to find the POI. But questions like these is what a little bit trickier. These are the kind of questions you want to nail if you want to get an A+. So what's happened here? So there's a trail mix. We have two blends. We have the first blend, which is $18 per kilogram, and then there's another one for $10 per kilogram. He's making 80 kilograms of the new trail mix, and he will sell it for $12.50. Austin uses the graph shown. Okay. Write the equations of the linear relations in the graph. I mean, we know what the y-intercept is, yeah?
Mm-hmm.
Look at this one. For the blue line, y is equals to the y-intercept is 100, yeah? Now
Uh-huh.
look at the slope. The slope is a little bit tricky. You can't use this point to find the slope. You can't use these 2 points to find the slope because that point down here, look at this, it's not very precise, right? What is that point? No one knows really. It could be 50, looks like it's 55, but we don't know for sure. So we're not going to use that point. We're going to use a point that we do know. What's a nice point here? This point looks nice, right? Yeah, let's go with that. So that on the y is 10, yeah? Which means the rise here is negative 90, going from 100 to a 10, negative 90, and the run going from 0 to 50, this is 50, that is our slope, or negative 9 over 5, you can say as well. Minus 9 over 5x, like that. What about the red line? What's the y-intercept of the red line?
It's 80.
It's 80, right? Now look at the slope. We're going from here to here, right? Those are both nice points. The rise is negative 80. The run is positive 80x. So you just get 80 minus 1x. And those are the two equations, okay?
Mm-hmm.
From the graph, how much of each blend will he use? Again, it's not very precise. That's why I don't like these questions. That one there, to me, that appears to be 25 kilograms on the X. So 25 kilogram of the pineapple mix. And what is this? You're not going to see this question on the exam. If you do see this question, that graph will have a lot more thinner lines on it. Like you can exactly pinpoint what that point is, right? This one, it's too broad. But that one appears to be 55 kilograms. And there we go. Okay?
Mm-hmm.
You can quickly verify if you did this right. 55 plus 25 is 80, and that's what he has. So that appears to be right. But again, that question, that point there is not very clear on what it is. Now let's do the same question without a graph, which is the next question here. I'm going to give this to you. X is the first blend, whatever it is. Y is the other blend. So we can say X is the Brazilian beans and Y is the Ethiopian beans, okay? You're going to get two equations. One of the equation is the weight, okay, or the kilogram equation. What is it? What does both blends add up to in terms of its weight?
200.
200. So that's our first equation. X plus Y is 200. Now the other equation is a little bit trickier. The other equation is the money. So the first one sells for $12 per kilogram. The other one sells for $17 per kilogram. What is that equals to? It's tricky. It's 3,000, okay? How do I know that? It's because she's selling 200 kilograms at 15 per kilogram, yeah?
Mm-hmm.
So this is the money made from one bean. This is the money made from the other bean. That has to add up to 15 times 200. Just think about the numbers. You can look at it that way as well, which is not the best way to look at it, but in the money equation, we have 12 times some kilogram, right? $12 times some kilogram. We have $17 times some kilogram. In that same vein, on the right side of this equation, you need to have some dollar, right? Which is going to be $15 times some kilogram, like that. And 15 times 2 is 30. 15 times 200 is 3,000. And this right here is tricky. Okay, this is going to be an A+ question. Getting this part is important. Everything else is kind of obvious, but that part there is not. How do we solve this? This question, don't graph it. It's because you see our scale, we need to go from 200, right, which is over here. When you go from 200, even if you go one box is 100 or something, then you need to go all the way up here somewhere, 15 boxes apart for 3,000. And when you graph it out, and especially if you meet somewhere like here, you see this point?
Mm-hmm.
What's that point? Who knows? Who knows? So I made graphing this is not the best, unless you use a graphing calculator, obviously. So how do you do this by hand? Pretty simple. You're gonna do substitution. In this question, it doesn't matter. In any of the questions, it doesn't matter if you let x equals 200 minus y or y equals 200 minus x. Usually you would want unknown to be over here. In this case, both of them are unknown, so it doesn't matter which one you solve for. Actually, let's solve for x because so far we've been solving for y. So I'm gonna let x be 200 minus y, and you're gonna take this 200 minus y and plug it into this x here. So you get 12 times 200 minus y, this is the substitution component, plus 17y is equals to 3,000. So this will be 2,400 minus 12y plus 17y is equals to 3,000. This will be 5y is equals to 600. That means y is 120. So there you go. Y is 120. You can plug it back in here to find x. So x will be 200 minus y, which is 120. It's going to be 80. And that's the answer. You want 80 of the Brazilian, and you want 200 of the Ethiopian. Okay?
Mm-hmm.
Did this make sense to you? Why this is 3,000?
It does.
Because if you put another variable here, z or something, then this system becomes unsolvable because we have 3 variables but only 2 equations. You can only solve for the same number of variables. Okay, so if you have 2 equations, the max variables you can solve for is 2. Let's do another distance question. I don't know why this picture is here, but we're gonna pull it up for moral support. All right. So he's going from somewhere to somewhere. He's going from Ottawa to Temagami. So Ottawa is here. Temagami is here. So let's say he goes like this. This total distance, okay, or maybe I should just draw a straight line, doesn't matter. That's not how he's gonna travel, but for our purposes, this total distance is 393. He travels at the first highway to North Bay. So let's say this is North Bay here. This speed here is 70 kilometers per hour. Then from North Bay to the other, the speed is 50 kilometers per hour. What else do we know? We know that the total time it took him is 6 hours. All right, so what are they asking us? I'm gonna first see what we need to put x as. It says use your graph to determine the distance from North Bay to Temagami. All right, so we're gonna say, see this distance here? North Bay to Temagami? That is going to be x, okay?
Mm-hmm.
So that means our y is going to be the distance from Ottawa to North Bay, like that. You're going to get 2 equations. The first equation is going to be the total distance equation. What's the total distance equation in terms of x and y? the total distance, x plus y, is 393. Okay, all the way from Ottawa to Temagami. That's the easy equation. The other equation is going to be the time, which is a little bit trickier. Remember, time is distance divided by speed. If the distance here is y, okay, from here to here, if the distance is y, and if the speed is 70, what's the time?
Y over 70.
Y over 70. So that's the time from O to N. What about the time from N to T?
X over 50.
X over 50. And we know that the total time it took him for this trip is 6 hours, like that. Okay?
Mm-hmm.
Step 1, I'm going to show you how to do this on a graphing calculator. Why graphing calculator, not by hand? Because that number there is not very nice. Okay, the 393 there, it's going to throw people off. So I'm going to plug these two equations in here. So I'm going to show you two in like 10 seconds. X plus y is 393, and y over 70 plus x over 50 is equals to 6. So what's that point though? That point there is that. Okay, cool. Let me highlight it. And that's the answer to this question, okay? So what does that mean? That means they intersect at 67.5. So that's our x. That's the distance from N to T, North Bay to Temagami. And on the y, they intersect at 325.5. That's the distance from Ottawa to the other place. And if you add them up, they should add up to 393, which it does, okay? So that is the answer. But you're not always going to get a graphing calculator on the exam. So how do you do this by hand? It's not that difficult. It is just a substitution question, and you just need to do a little LCD. Here, let me show you. So what was our x? X was N to T, okay. So we're solving for x in this question because they want the distance from North Bay to Temagami. Whatever you're solving for, make sure that's on the other side of this equation here. Right there, okay? Now we're going to plug that as y in here. So 393 minus x, this is a substitution component there, the y becomes 393 minus x, plus x over 50 is equals to 6. How do you solve this linear equation for x?
You find the common denominator.
What is it between 70 and 50? It's the same thing as between 7 and 5.
It's 3,500.
350. You don't have to go to 3,500.
Okay.
Because 70 goes into that 5 times, so you're going to multiply this by 5. Multiply this by 5 to get 350. Multiply this by 7 to get 350 for the other guy. So now let's open that bracket. 5 times 393 is 1965. 5 times negative x is minus 5x. Plus 7x all over 350 equals 6. Multiply both sides by 350. You get 2x plus 1965 is equals to 6 times 350, which is 2100. Subtract 1965, divide by 2, and that's how you get x is equals to 67.5. Plug that back up here to find y. So y would be 393 minus 67.5, which is 325.5, okay? So this is not that difficult as long as you know. The math portion is just an LCD question, right? And solving a linear equation. This part isn't that difficult. The difficult part is this right here, coming up with this equation. The first equation is pretty simple. This equation down here is a little bit tricky. You need to know things about distances, times, and speed, the one equation that you need. And doing this by hand is not really feasible because where's 393? Let's look at the graph again. Like, look at this. Every box here goes up by 25, right? Because actually, every box goes up here by 50 even. So how do we know that's 393? We don't. Oh, well, we do because this is the technology. The computer does it for us. But when you do this by hand, you don't know that that's 393 because each box is like 50 units, right? You could end up at 392. You could end up at 395. That's why some questions graph is not the best way. But you can always use it to double check your answers. That's the good thing about graphs. This one is maybe a graph question because the numbers are pretty small. This is the kind of question you'll see if they ask you to do something by hand. So 3 meters of denim and 5 meters of cotton fabric was bought. The total bill was 22. And then Jared bought 6 meters of the first, 2 meters of the second for 28. Now they've kind of stated what X and Y is. What do you think X and Y is? X is the amount of denim, okay? Y is the amount of cotton. Cool?
Mm-hmm.
So the first equation here becomes 3x plus 5y. 3x plus 5y is equals to 22. What's the second equation?
6x plus 2y equals 28.
Yes, 6x plus 2y equals 28. Actually, we're going to graph this, so let me just put it up here. Okay, so how do you go about graphing these guys? So ideally, you want to find some nice points, okay? For the first equation, look at this. For the first equation, this one's a little bit tricky because if you let x be 0, then you're going to get y as 4.4, which is not a number we want to deal with. We want exact whole numbers, okay? So don't let x be 0 in that case. I'm going to let x be 4. So 3 times 4 is 12. 22 take away 12 is 10. So that means y is going to be 2. Do you agree?
Mm-hmm.
Is there any other nice numbers we can use? What's another point we can use for the first equation? The second one is easy. No, there's not really any other nice points we can use for the first equation, right? Can't think of anything. Yeah, we're stuck. What that means is we have to deal with a decimal number, which I'm not a very big fan of, but it's okay. I'm gonna let x be 0. That means y is gonna be 4.4. Okay?
Mm-hmm.
So let's go here because we don't really have any other whole numbers, no matter what you plug x and y as. So the first point is easy. It's 4. So 1, 2, 3, 4, and 2 on the y. 1, 2. So that's our first point. The second point is 0, 4.4, which is not that easy to graph. So 2, 3, 4, 5 is here. 4.4 is going to be somewhere there. And then you connect those. Why are we doing it this way and not using the slope and the intercept? Because 22, 28, you see that? We're going to go out of the page. This page only has 20 lines, right? So if you want to use the other approach, you need to first convert it into mx plus b. Then you need to find 28, which there's not enough space here. The next equation is a little bit simpler though. So if I let x be 4, what's going to be my y value here? If x is 4, y would be 2. Look at this. 24 plus 2y equals 28. 2y is 4. X is going to be 2. So that's our first point, which is also right there. The next point, let y be 4. Or not 4, sorry. Let x be 3, I guess. So 18, 28 minus 18 is 10. 10 divided by 2 is 5. That's another point. 4, 2, and 3, and 5 right there. Okay?
Mm-hmm.
That's our second point, and then you just want to connect them. They meet right there. What does that mean? Remember, X was denim and Y was cotton. That means denim costs $4 because that's our point of intersection, and our other guy costs $2. That's the answer to part A and B. Part C, how much will 8 meters of denim cost? That's going to be 4 times 8. 5 meters of cotton, well, that'll be 5 times 2. 32 plus 10, $42. And that's the end of this question. Okay?
Mm-hmm.
So the main point here being you don't have to always convert it into this form to graph a linear line. Sometimes, as you saw in this question, it's actually easier to just plug in some points and get rid of it instead of going all the way to 822 or something. All right, let's call it a day there.
Okay, thank you.
See ya.